My name is Max Williams, and this is the Anti-Vibration System from Tri-County Regional Vocational Technical High School. Our group members are Drew Urquhart, Ryan Kester, Max Williams, Joe Curtis, Richard Hepburn, and Gavin Crozet. Our shop teacher is Mrs. Magus. We have been tasked with creating a system that will cancel out some of the rigorous vibrations from takeoff and landing of a rocket traveling to and from the International Space Station. Our system will make sure that any equipment or objects placed inside will stay secure and undamaged during the trip. Some of the constraints of our system is that it must not have any free-flowing liquids, so there's no leaking, and it cannot be made out of any flammable materials, so there is no ignition. It has to be easy to access and must support an object up to 15 kilograms. The device must also fit inside the provided mid-deck locker on the rocket. Over the course of our project, we generated many ideas and concepts on what our system may look like and be made out of. Our first idea was inspired by a Bose suspension system that canceled out almost all vibrations caused by the road. The spring and damper isolation system would consist of spring and damper mounts mounted on the X, Y, and Z axes that would be linked to an outer box and an inner box. The inner box would hold the object or objects and limit the vibrations traveling to them. The next idea was a rubber band isolation idea. It would be a frame with a box for holding the object or objects inside, suspended by high-strength elastic bands. Since it would be a free-floating box, it would limit vibration, and since it was connected to rubber bands, it would have free will to move, but not too much as to rupture the objects inside. The padding idea was to use rubber sheets from a company called Sorbethane and have these sheets cancel out vibrations. They would be layered and absorb vibrations very well. Some of the materials that we might have made our box out of that we considered were neoprene, the Sorbethane rubber, Kevlar, acoustic dampening sheets, foam cushioning, and for our actual box, titanium, steel, diamond plate steel, and aluminum. A large part of our decision-making process was decision matrices. This was a collaborative effort as everyone in our group had input. It involved research into each category of criteria for each concept and idea. The scores of each idea helped us make an accurate and efficient choice. On this slide, our final choices are presented. For the materials of the container itself, we chose aluminum because of its durability, light weight, and ability to cancel out some vibrations. For the box design, we ended up researching two system designs at the same time to ensure we made the right choice. We still continue to research each design and will make our decision when we test the prototypes. For actually attaching the system to the mid-deck locker, we chose bearings because they are easy to attach to and easy to install. We decided to use foam cushioning as padding because of its shock absorbance and ability to mold around objects. The first design is the Sorbethane anti-vibration leveling mounts. These mounts cancel out vibration and will be mounted on the X, Y, and Z axes. The special Sorbethane rubber pucks on the leveling mounts cancel out vibrations. The actual container of the system will be lined with foam cushioning and have an easily accessible hatch on the front to place and remove objects inside. The aluminum plate on the bottom of the system would attach to the mid-deck locker by either being bolted down or by bearings. The second design is the suspended elastic band system. This system suspends a container for the objects from a frame by high-strength elastic bands. These bands would pull on all 8 corners of the interior box in all different directions to prevent the entire system from becoming a rigid body and to prevent torsion. The interior box would have enough freedom to slightly move around, but not too much to be affected by torsion or to become a rigid body. This system is tunable by changing out the spring constants of elastic bands for higher or lower value to cancel out vibrations better for the given environment. Like the other system, the actual container for the objects would be lined with padding to prevent damage to the objects and the contents, and would include easily accessible hatch for storing the objects inside. Thank you very much for viewing our slideshow and project, and we hope to hear feedback from you.